important is that he calls you paprika, so that helps me remember. When I say it, but I won't call you paprika unless you want me to. So we're going to start with limits. We'll start pretty basic, and the worksheet I gave you, that packet that I have given you guys is pretty basic still. Then we'll get quickly more in depth. Why am I spelling limits weird? Because limits are y values. So this is kind of trying to reinforce it. But when I ask you for a limit, I'm looking for y values. So limits are y values. Graph is headed towards at a given x value. Whether or not f of x exists, where it is, doesn't matter. Write down those. We'll do a couple of these little mini checks. How about I get 10 out of 10 on that quiz? Nobody thinks they're good? Okay. I'm going to think they did well on the quiz. Okay, cool. Just be afraid to say 10 out of 10. Right, gotcha. So I'll help you guys over here, because you can see this too, if that's easier. Not look at the layers. Yeah, like your little TV over there. So, first of all, just kind of the basic stuff. If there's an open dot there, that means there's not really a value of the function there. So if I said to you, what's f of 2? I'll add that on there. Part f. I know it's like a weird order, but if I said what's f of 2, that means what's the y value of the function when x is 2? It doesn't exist. There's not a value there. There's not a y value at that spot. But I can still find the limit as x approaches 2. So the limit doesn't care what happens actually at 2. It's really just like what's happening right around 2. What's happening at 1.999 and 2.0001. So as I travel toward x equals 2 along this graph, what y value does it look like I'm going to end up at? 2. I never get there. But that doesn't matter for limits. Limits is like where you look like you're headed. Whether or not you get there doesn't matter as far as limits are concerned. So like let's say I walk halfway to that door. And then I stop and eat a sandwich or something. I walk halfway to the door again. I take a nap. And then I walk halfway to the door again. Text somebody. I just keep going halfway, halfway, halfway. Mathematically, technically, will I ever get to the door? No. But what's the limit would be the door. So it looks like I'm going to get there. I'm going to get really, really close. I might not ever get there, but that's where I'm headed. That's where it looks like I'm going. Sometimes they're the same. So if I said, what's the limit as x approaches 1? Well, what's the value at x equals 1? What's the y value? 1. What does that look like the y value is heading towards at x equals 1? 1. So they match. So the value there and the y value it looks like we're headed towards are the same thing. So this one's 1. And then if I start to look at x equals 3, so if I zoom in on this part here, as I'm traveling along this graph, as I head toward an x value of 3, from either side, what y value does it look like I'm going to end up at? 1. So I'm heading towards this spot here, which is a y value of 1. What value is it actually? So what's f of 3? That's saying when x is 3, what is the real y value? Like where's the closed dot? That's at 3. So whether or not, so if this dot didn't exist, what would the limit as x approaches 3 tell you? If that dot wasn't even there, what's the limit as x approaches 3? 1. If that dot is where it is, what's the limit as x approaches 3? 1. If that dot moves into this open circle, what's the limit as x approaches 3? 1. So does that dot have anything to do with it? Not at all. So like right here, if I put, what's the limit as x approaches 2? 2. If I put a closed dot way up here, what's the limit as x approaches 2? 2. If I put that closed dot in the circle, what's the limit as x approaches 2? 2. So where the dot is doesn't matter. It's just like where we look like we're headed. Right? This is getting a little more, like a couple more days down the road, but as x goes to infinity, so as the x value goes this way, like as I travel further and further to the right on the graph, what's the y value doing? It's going up forever, and we would say the limit's positive infinity. Let's do one more like similar. So I'll make a little graph again. So write this down and then try these questions on your own. And then I will go through them with you. So you should be good now that it's like a normal day. You should be fine. Remember when I ask you for a limit, that's a y value. What's the y value we look like we're going to? I don't care what happens when we get there. I don't have to know what happens at that spot, just where it looks like it's going to end up. Sure. Oh, I just made it up. But yeah, it looks like it. But then these would be like pi over 2 and pi, and I don't want to get into that. But sure. But that wouldn't go up and down forever at the end, though. It would keep looping. Yeah. Okay, so at 0, so the x approaches 0, so now we're looking right here. As x goes towards 0, so I kind of check from both sides, what y value does it look like we're going to end up at is 2. F of 0 is where do we actually end up at? Like what is the y value of the actual dot? And that's 1. And again, if I moved this dot into that circle, would that change the limit? It would not. If I took the dot off the page completely, would that change the limit? It would not. So what this dot, that's what this right here means. Whether or not fx exists or where it is doesn't matter. So let's say like this dot here, I could slide it anywhere I want or remove it, and that does not change the limit. Limit as x approaches 1, so it looks like we're heading toward a y value of 1. F of 1 is what's the y value of the actual dot, and there isn't a dot. So that doesn't exist. As x approaches 2, it looks like we're heading toward a y value of 2. The actual y value when x is 2 is 2. So those match, and that's called continuous. When they match like that, that's one of the next things we're doing. That's called continuous. Then x equals 3. The limit is the y value that we're heading towards, which is 1. And f of 3, again, doesn't exist, and I could put a dot there, up here, down here, anywhere I wanted to, and that would not change the limit. Right, question on that one? Okay. So the next thing is for the limit to exist. It must be the same from both sides. So it has to look like it's heading toward the same y value from both directions. So you get what's called one-sided limits to worry about also. So remember, like, this is the positive direction over here, and this is the negative direction over here. Have you guys all seen Mean Girls? Do people still watch Mean Girls? How many have seen Mean Girls? They used to be like, everyone has seen it. The limit does not exist. The older I get, the less people understand my movie references. Try to Mr. Porter scene. Not soon. 50 years. Right?
Yeah, it's not quite cramp. It's just a dull-ish pain in my shoulder that happens every once in a while. It's in my shoulder, not in my chest.
Well, I think they're... Alright.
No, these have been often enough in park cars, nothing like that. It's just weird. These are things that I'm actually exercising every morning now. That's Rick swings in the morning because I don't know.
Okay. So, if I asked you for the limit as x approaches 1, in this case, you'd have to say it doesn't exist. So let me get into why. If you were traveling toward, so let's do the one-sided limits. As I approach x, as x approaches 1 from the right. So you find x equals 1 on the graph, you go just to the right of it, and then start heading back towards x equals 1. That's what the 1 plus means. It means you start from the plus direction and head back toward that point. What y value does it look like we're heading towards? 1. As I approach 1 from the negative, so that means I'm going to go just to the left of 1, like just on the negative side of 1, so a little less than 1, and start heading back towards 1. What y value does that look like we're approaching? 2. So if I asked you for the limit as x approaches 1, just in general, you wouldn't even know what, you can't really decide which one to pick. So you got to say it does not exist because it's different from each side. Okay. Is that right? How many had that filled out before I even... Okay. Like, I'm not really quite clear on how in-depth you guys went with this stuff last year, but that's cool. So what I want you to do is try that entire packet. They go really quick. Like, I mean, it's like 50 questions, but they go really fast. So it's not, it looks a lot more work, like a lot more work than it is. I think the first, like the typed up questions, I think are pretty easy. And the one on the back, I wrote, and that's got a little more stuff in there, some of it we haven't even gotten through yet. Do what you can, we'll check it, and we'll go over it tomorrow, and then we'll practice whatever we need to practice. Yeah?
Okay, so for like the first 4, it looks like, not 4, but like the first 3, it looks like they're not, like this one, it looks like it's like at a decimal. Like for 1.
Yeah, so, okay. Yeah. So for right now, like if I look at number 1, as x approaches 1, we're like a little less than a half, right? Like it's between 0 and 1, but on the bottom side. We're going to learn how to do that algebraically. We're going to go through how to do it so you can actually find the actual thing. But for right now, if you put a third, if you put a half, you put a fourth, like those are all okay. The answers are always attached to this. So you can just in your head be like, well, I know it's like somewhere around like a little bit above 0, and then if I look at the back, it's 1/4. So as long as the 1/4 makes sense to you, you kind of know where you are, then you're okay. So there's like 28 questions, and then an answer sheet, and then 36 questions, and then an answer sheet, and then this thing on the back. There's like 60 questions. I'm a jerk. Look at all this homework I'm doing. No, but I mean, I think it'll go really fast. So one thing you could do, if I'm trying to estimate this, what could I try instead of estimating? Plug it into the equation. Typically what's going to happen, and it'll happen in this one, is you're going to get 0 over 0, which doesn't help you at all. But sometimes it will. So sometimes if you get stuck, you can plug it in and be like, oh yeah, okay, I can actually figure that out. Questions for me? The answers to this, I didn't give you, so we'll check that over first thing tomorrow. Kind of go through each one at a time, and then we'll practice more of that.